Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna continue with the color grid exploration, and today we're gonna have a look at the distance node and how this can affect our color grid. So you know how to get the drill. You know how to get this node tree, and you just need to load it from Gist. Once you have it working like this, then you're ready to go. Okay, so we have this, and we can colorize the grid using RGB and with whatever value we plug into this guy. So we're gonna save this as SV color grid distance. We probably have used distance nodes a few times in the past, and we just need to kind of apply it into this grid. So again, the grid is like you can think of it like an array, right? Like an array. Instead of thinking of the grid like a list of numbers or of items, we think of it like an array. And in this case, we have an array of points that's for the kind of correspond to the location of each polygon face. And for that, we can really use the position of each points and kind of using the distance node and to get the output, and we just need to compare it with another point. So I'm gonna do just that. So we have this point position, 100 point positions for this 10 by 10 grid, and we also have this we can use this vector in, and comparing the two with the crossover being checked, we should get 100 value out, and it's based on the distance. And if we just plug that into our grid, we should get something. See, I should not move it in the z-axis, otherwise it's gonna disappear. So we have this guy. It's kind of okay, it's kind of working, but we know that the value is kind of like super huge sometimes. The distance range from 0 until like a whatever value that's like the points that the furthest away. So we need a way to kind of map the color. So for that we use something like map range. Let's try that real quick. So alt min, alt max, new min, new max. We can try alt min, alt max, and we kind of adjust the new minimum and maximum and kind of get a result here. Starting to get somewhere. Don't know exactly the maximum value here. We probably can use a max from here, but just gonna eyeball it. We seem to be getting something. This is 10 by 10. If I increase the number of polygon here, let's say make it like 40 by 40, so it's 1,600 polygons that we have now. We should in theory get a way to work with, you know, more data, and we can kind of see it more clearly sometimes. So now we started to see something. This guy is actually supposed to be black, but I think the vertex pane maybe it has some kind of alpha somehow. If I try to render it out, this should be black. Or maybe it's kind of gray in this case because of this. Okay, that's better. I should make this between 0 and 1, and that's the value minimum and maximum, kind of like remapping the value. We can get it like super tight, so we have just like a circle. This is one way we can use to generate like a circle kind of pattern, and we can control this kind of the radius, and we have this result. We can blur it if we kind of make the distance, this value and this value is kind of further away. Okay, so that's the theory. We can have like a, this is supposed to be like a, okay, red and black. If we want kind of the inverted value, we can use, I believe we can use math. And what should we have? Absolute can, no, negate, actually not negate. We don't have inverted, maybe we just use 1 minus. Yeah, 1 minus the value is kind of inverting the value. So we have the red influence, like so. And of course we can still control it using this other value that's comparing 1 points, which is this one vector points, with 1600 other points. I'm gonna reduce the number so it's gonna be a little bit faster, a little bit more interactive. Let's adjust this a little bit. Okay, so we have this now. What else we can do is just maybe we can use a sine wave. I have not tried this, but maybe this is gonna work. But a sine wave in the, maybe in the z-axis. I don't know if this is gonna work or not. Sine in the z, so the z-axis kind of controlling that kind of value. I'll try like using a range random number, for example, float between 0 and 1. Let's try. Oh, actually it doesn't work that way. The distance, maybe we can plug this guy into this guy and look at the result. Sine does not do much in this case. Maybe I have to do it differently with other functions. Try multiplying it. Multiply didn't do much either in this case. Well, actually I was wrong. This does give some kind of effects over here. So I'm kind of curious what's this gonna give us if I play with the value. Maybe even with a modulo. If I use a modulo in here, modulo, and then we might get some kind of like a surprise, because the modulo actually gonna do some kind of repeat. Although that's really depends on a lot of other attributes. I'm gonna increase the grid once again, and then kind of push this and push that. Min and max and clamping. Okay, clamping, if I turn it off, actually we have super interesting result here. Like I said, the modulo is actually something I forgot to mention, but it's doing the repeat. And yeah, you can see here, that's the effects kind of happening. Modulo 2, 3, 4, maybe smaller value give it more interesting repeat. If we just use the sine wave, it looks like that. Actually, sine wave give you like a ring. It's pretty interesting. We don't actually need the modulo in this case. The sine and maybe multiplier in here. Kind of, this actually give you control over kind of level or contrast. So that's also interesting. That's controlling. This is controlling the invert, so I shouldn't change that. but this is controlling the size of the sign. Yeah, very interesting. I didn't realize that. Quite possible. File save. Maybe we can do one more thing. In this case, we can use vector noise or even fractal. Vector fractal gonna give you, if we just plug in the output of the sine ring into this guy, we gonna get noise anyway. I think we should be able to do that. Maybe this is better actually for the system. Doesn't vector. I think we shouldn't do it this way. We should do it so I plug in the vector position here into the fractal, and then the next thing I will do is kind of combine the two using math, whether it's addition or multiplier. It's gonna combine the effects like so. So now we have something completely different. Of course, this is like a fractal noise, and we have all kind of different result here on top of the ring pattern. So this again, super interesting. And then if you are ready, you can always increase this resolutions. You can go maybe 1000 by 1000, which is becoming like 1 megapixel of an image. But again, once again, this is like a good preview if you wanna work with a shader, whether it's like GLSL kind of shader or OSL, open shading language of Blender, also works in a similar kind of way. Instead of the point, in this case we have like a point positions that's kind of going through the sine wave and then the vector fractal, and to get this kind of pattern. This is of course like a recipe for procedural pattern. Still pretty basic, really. This is not like a big deal. So I'm just changing the center point of the circle. I still have control over this ring pattern, and of course the fractal. So they all have some kind of effects. Modulo is useful for repeating. In fact, if you use the modulo for the gradient, you get like a gradient and then another repeat of the gradients. It's like it's kind of like a list repeat. Modulo is giving you like a loop. Same sine is kind of doing that as well, because sine wave is like doing that, and then it's like a repeating, while modulo is more like something like that, I believe. I multiply these two, we get that. I think addition is better. Vector in. If we use like different color, maybe it's gonna be interesting as well. So two kind of fractal for red and green. Let's see the result. If we mix the two together, yeah, we have this kind of pattern that looks like maybe a little bit like a lizard skin or something. Let's kind of mix this guy and this guy. We have, yeah, something like that. There is actually one more thing that you can do. It's using lerp, vector lerp or vector evaluate. These actually give you the effects kind of like mixing of two color, believe it or not. So if we have vector in for vertices A and vertices B, maybe red and blue, so these two color combined together, we should have, you know, red and blue, and then the vector is coming from the fractal, etc. And then the result, as the result, we have a single color based on the ring and the fractal. Again, this is like maybe completely like bizarre kind of effects. How is this even possible? That's because of the array of points that we use. It's all started from here because the array of the grid, you know, the grid of points that we already have, we're simply using the distance, and then distance combined with the sine wave, and then we started to get that kind of effect. I think procedural texture it is kind of bizarre. There's a lot of math, and it's kind of like a super big subject that even me still like trying to understand it. I sort of touching the basic here. So you can mix red and blue, or blue and cyan, giving different color. Yeah, so we came up with this, something a little bit psychedelic, even though yeah, it's not. Maybe it's like an eyeball of some kind of creature, like a chameleon. Although we can try, maybe one day we can kind of generate like something that's more like that, more interesting. So, procedural shader, of course, it's not always this kind of abstract. Sometimes you look at the nature, and then you try to mimic that kind of pattern, because nature is always the great source of inspirations, and you can always find some kind of pattern, some kind of rules in the nature that you can supposedly you can replicate using using math and functions. It's not always that obvious, but yeah, just give it a try. This is definitely worth kind of playing around. Sine and tangent. So tangent give you completely different design. Negate, sine, back to sine. I like the sine. Okay, so yep, that's pretty much it with this live noding. If you have any question, suggestion, you can ask me down below. I'm gonna take a quick snapshot of this video. This is for the cover. Okay, thanks again for tuning in. I'll see you in the next video. Thank you. Bye.